Okay. We have a trapezoid, right? Where the height is 4. This is your height, right? And your base. Which one do you want to be base 1, top or bottom?
Top.
Top? Okay. See, I always go with the bottom, but it's all good. So 1, and then base 2. It doesn't matter,
Yeah.
right?
No, it doesn't.
So what do we need for area of a trapezoid? Yeah.
Base 1 plus base 2 divided by 2 times what the thingy, the height.
The height. There you go. So we might want to define that, right?
Yeah.
So like she said, base 1 plus base 2 divided by 2. So it's the average of the bases, right? And then
Times 4.
times the height equals
Area.
the area of what?
A trapezoid.
Trapezoid. So if you want, you can put a shape there. You can put T there, right? You can put TR for trapezoid, because sometimes if you put T for triangle and trapezoid, it's kind of confusing. I always like to put shapes, but sometimes the shapes get frazzled, because like once you have octagons, and now it's like putting a nonagon down there is like really hard, right? So I noticed that it's getting difficult once we were trying to do trapezoids versus just a quadrilateral. So think about this real quickly. Would this work for any rectangle?
No.
Why not? Is a rectangle a trapezoid?
No.
No.
Why not?
Size are slanted.
Is a square a rectangle?
Wait, no, there are.
Remember your Venn diagrams?
Aren't the sides like equal?
Right? Can a rectangle be a square?
No,
No.
a square can be a
Wait.
rectangle. Wait, no, a
Wait.
rectangle can be a square, a square can be a rectangle.
You know, I
Something like
didn't
that.
think
I can't
Right,
remember.
right. So a square is always a rectangle, right?
That's
It
right.
is?
But a rectangle isn't always a square. It has to be a special rectangle, right? So in the same aspect, a special trapezoid could be a rectangle, right? Because the definition of a trapezoid is what? 2 opposite parallel sides. What's the definition of a rectangle?
4.
4 opposite parallel sides, but also, because that's a parallelogram, that have to have a
Equal.
right angle for every corner, right? That's a rectangle. Every corner has to be a right angle, right? But if you have 4 parallel sides, do you have 2?
Yeah.
Yeah,
Yes.
right? So think about it. Use what you know to figure out what you don't know, right?
Yes.
If I had a rectangle, and that rectangle is 7 and 7 and 5 and 5. The area is 35, right? Do we all agree?
Yes.
Okay. Now, if I took this and said, because this is a right angle, right? If I said 7 plus 7 divided by 2, what would I get? 7. And 7 times 5 is,
35.
oh, it seemed to work. Just something to think about. All right. So, all right. Let's get back to the problem at hand.
Yes.
Plug it in. Plug it in, plug it in. What do you got?
Plus 5 plus 12 over 2
So
times
the
4.
area of a trapezoid is equal to, oh, what is this called, by the way?
Definition of the area of a trapezoid.
There you go. Definition of the area
That's.
of a trapezoid.
Yeah.
You mean to say that's.
Okay? And then we plug in what?
The 5 or the 12.
Okay, 5
So you have 17.
cm plus 12
12
cm all over
2
2
times 4.
times 4,
Right now it's 34.
CM? right?
Yeah,
Okay. Then what? Oh wait, what's the property there? What'd you do?
Substitution.
Substitution. Okay? Then what?
And you combine like terms.
Combine like terms. So in the parentheses first, right?
Yes.
Okay? So the area of a trapezoid equals 5 and 12 is what?
17 M.
17 cm over 2, right?
Uh-huh.
Times 4 cm, right?
Uh-huh.
Really over 1, right? Okay? Sorry. Okay? And then, and what was our first step? It was simplify, right?
Yeah.
Inside the parentheses.
Yeah.
And what did we do?
Addition, subtraction, left to right.
Good. Addition and subtraction left to right. And then what?
We,
There's like, there's two different ways. You can divide the 17 from the 2.
Right.
And multiply the 17 from the 4.
Right. So I like the easiest way.
I like to do the 4 and 17.
So 2 goes into 4 how many times? Now here's something that I teach my students, how to break down fractions. And it's called upside down division.
Upside down division.
And what upside down division is it lets me figure out what I can pull out of both the top and the bottom at the same time. So what goes into the 4 and the 17 that also goes into 2? So what goes into 4 and 2? 2. Right? So how many times? So the 17 I don't have to worry about because I only have to pull out of one of the things that are multiplying on top. Does that make sense?
Yeah.
So the 17 is still there. The 4 changes into a 2 cm. And the bottom gets rid of the 2. And then this becomes a 1 and a 1, right? And so we really don't worry about those things anymore. But that was simplifying with respect to what? Multiplication division from left to right, right?
Yes.
Okay. Now what?
And then you can multiply the 17 centimeters to the 2 centimeters.
Right.
You get 34.
So I got the area of a trapezoid is equal to 2 times 17, which is 34,
Yes.
right? And cm times cm.
Centimeters.
Centimeter squared.
There you
So
go.
yes, it's squared. I don't really think
Okay.
it's very hard.
And then what did we do there?
We,
I multiply
division by
multiplication.
multiplication and division.
Yeah. What Phoenix said.
Right.
Mhm.
So we're still simplifying. But see how we simplified 3 different ways?
Yes.
We had to do each one, right? First it was in the parentheses by adding. Then we divided really, right? We took 4 divided by 2, right? We did it a little bit different way, but that's what we did. And then we multiplied.
And we
Right.
got-
So we divided before we multiplied, but it said multiply from left to right. So shouldn't you have multiplied first?
No, it's multiplication and division from left to right.
Yes, multiplication and division from left to right. So whatever comes first, right? From left to right. So in our case, we decided, because remember, if they're all being multiplied, we can multiply them in any order, right?
Yeah.
Just like if they're all being added, we can add them in any order, right? Associative property, or in this case, cumulative property, because there's only 2 pieces. Right? All right. We good?
Yep.
Any questions?
Nope.
Sure.
Yes, 100%.
All right. All right.